it is 12 and we are back together for our third webinar this day. This one will be about environment and climate change and about experiments in the Caribbean region that shape new opportunities. So we have here special guests to talk about this subject. We have Elodie Afonso, who is Project Officer for Climate and Territories for the French Development Agency, the Agence Française de Développement. We also have Sarah Gaspard, who is Professor of Chemistry at the Université des Antilles, Professeur de Chimie à l'Université des Antilles. And last but not least, we have Crispine d'Auvergne, who is Climate Change and Disaster Risk Management Coordinator for the OECS. Bonjour à tout le monde, je fais une petite présentation en français. On va faire ce webinaire-là, donc c'est le troisième de la journée. On va parler d'environnement, de changement climatique et on va parler d'expérimentation dans la Caraïbe qui peuvent procurer de nouvelles opportunités, de nouveaux débouchés et de nouvelles pistes d'avenir pour cette belle région. So first off, we're going to start with Crispine's presentation. There we go. And Crispine, I give you the floor. Maybe you should unmute your microphone. Are you getting through? Ooh, one sec. You just have to click on the little microphone icon. It's not working.
Yeah,
yes,
it disappeared for a minute. So okay. Thank you and good day everyone.
Good day.
And thank you for the opportunity. So today I'm going to be speaking on opportunities for research, learning and innovation with respect to climate change. So next slide, please. So yes, I think it is fair to say that the Eastern Caribbean is one of the most hazard-prone regions in the world. We are exposed to volcanic eruption, to seismic activity, that's earthquakes and so on, storms and hurricanes and drought, just to name a few. And from the pictures you can see here, the one on the top left-hand corner is Montserrat with the volcanic, the volcano erupting, and below is some of the fallout from the ash after the eruption. Well, it's had many eruptions since 1995, although it's been calm for it's been quiet for the last couple of years. Hope it continues that way. And on the top right, you can see some of the hurricane tracks for 2017. What is one of the busiest, but not the busiest hurricane seasons in a long time. And below you can see we had 3 hurricanes in that year in 2017, including Irma and Maria, category 5 hurricanes in the Caribbean all at the same time. Next slide, please. So climate change adds a new layer of hazards. For example, we're looking at sea level rise of up to 1 meter in the future. We're looking at stronger storms, not necessarily more storms, but more of the storms that pass through the region will become category 3 or higher. We expect to see more flash floods, that's the projections, and higher storm surge, higher temperatures of 1 to 5 degrees Celsius more by 2100. Heat waves, less rain. It is projected for the Eastern Caribbean that rainfall will decline by 25 or 30% by 2100. And we will also see more drought. Now it's interesting to know that while we will see less rain, we may actually see more rain in extreme events. So when you have storms, you will actually see more rainfall during the storms, although overall the annual rainfall will be less. Okay, so next slide, please. Now, what are some of the impacts of climate change? Now, there are many, many impacts, and we don't have a chance to go into all now, but I just picked out a few for some of the areas. So for example, in water, we're going to see higher demand because populations are growing and industry is growing and so on, but you will see less water because of the decline in the rainfall. We have seen before, and we will continue to see storm damage to dams, to the reservoirs and your distribution systems like your pipelines. Now, because you have less water available, then you can expect to see effects on human health, in terms of health and sanitation, for example, agriculture, because agriculture needs water, plants need water, and livestock, animals, tourism, etc. In terms of agriculture, storm damage to crops, that happens, we've been seeing that for years, but it's going to get worse. Drought damage, pests and diseases, because at higher temperatures, you very often get increased reproduction of pests, changes in soil fertility and soil health generally. And one of the curious things about climate change is that it's bringing increased variability. Nowadays, you can't tell when it's going to rain or when it's going to be, it's going to, when you're going to get, when it's going to be sunny or when it's going to be dry. So that very often confuses our crops. So crops that sometimes would bear in February, now they might bear in March or not at all, 3 times a year. I've seen it in my own backyard, so I can tell you it's a fact. Then our coastal ecosystems, we see coastal flooding, coral bleaching, ocean acidification, submerging of coral reefs and seagrass beds because as sea level rises, and changes in fish migration patterns, just to name a few. Next slide, please. With respect to housing and buildings, storm damage, of course, higher indoor temperatures, and with human health and wellness, greater risk of vector-borne diseases because higher temperatures change the rate at which some, like mosquitoes and some other pests, other vectors reproduce, and the diseases that they carry sometimes change. They change the pathogens. The reproductive cycle changes with changes in temperature, for example. And higher temperatures might bring certain vectors into areas where they were not before because of the changes in temperature, especially in higher mountain regions. Then we have a higher risk of hygiene-related diseases because people don't have that much water, to keep clean and to make sure that they can practice good health and hygiene. Increased risk of heat stroke, and that came out very strongly in a report that we did for the region that was under the adaptation facility with the kind support of AFD. And increased heat can also affect learning in children. And storms in particular can cause damage to health facilities. So these are just some of the impacts, and we can talk about it in forestry, in fisheries, and go to much greater detail, but we don't have the time here. Next slide, please. So climate change it's going to challenge, and it's already challenging every aspect of life, economic life, in terms of social life and everything. It's even affecting sports. And we can do an entire presentation on climate change and sports, believe you me. And it calls for a wide range of effective and innovative solutions. Next slide. So we are learning more about climate change every day. There's research papers coming out almost by the day. But there is so much more that we need to understand, to plan for, and to respond to. Next slide, please. So what are the opportunities for research, learning, and innovation? Well, on the left, you see the top left-hand side, you see a coral reef. So we still need to understand there's so much more to learn about, for example, which species of coral are most resilient. What are how is coral, changes in ocean temperature and ocean acidification? How are these affecting the relationships between species, between corals and fish, between one fish species and another? How is it affecting migration, reproductive cycles? So there's a lot of work that can be done to help us to find some of the answers, and so we can apply the solutions. Water supply, how do we get creative in terms of finding ways of conserving water? Is it through reducing losses of water in the distribution system? Is it through introducing energy renewables into the water distribution system, especially in the mountainous countries, for example? How do we increase efficiency in distribution of water to plants in the agricultural sector? How do we manage our forests and the biodiversity that lives in our forests? In fact, I remember my friends when I worked with the government of St. Lucia, I remember my friends in the forestry department were telling me once that there was this species of bird, I think it was a parrot, that nested at a certain time of the year, and another bird that would nest in the same tree after the nesting season for the parrot was over. But when the rainy seasons began, and the patterns began to become unpredictable, you would sometimes find those two bird species competing for the same trees. Okay, and so there's a lot to understand. Agriculture, likewise, human health, the interaction between vectors and pathogens, and between and humans, and how that impacts human health. What are the creative solutions that we can take to make our health facilities, our hospitals and health centers and clinics more resilient? In the construction sector, I think there's a lot of creativity that can be shown here and learning, because in some parts of the Caribbean, certainly where in my country, I see a lot of people, that's St. Lucia, I see a lot of people building houses what they call open rafters, where they remove the ceiling, and then they think it looks pretty because the rafters are nice and varnished or painted, but the old traditions that we had, where we had the ceiling, it was there to help to keep the house cool. All right. Some people didn't want it because they said it brought bats into the house. So there may be ways we can look at how we can bring some of these old technologies or modify them. And the same goes for our roads and other critical buildings and infrastructure. In terms of solar and energy, there is certainly the opportunity to blend the adaptation with the emissions reduction that solar delivers by learning how to design our houses to withstand hurricanes while at the same time generate electricity. And certainly in the health sector, that's critical when you have the electricity knocked out because of extreme weather, and then you still have to keep the medication cool and so on, and be able to help people in whether it's emergency operations. So these are some of the things that we can look at. And of course, transport is another. And there's certainly capacity for training people in some of these areas, because they still, for some regions, some countries in the region, they're still emerging. Electric vehicles have not really taken off to a great degree and so on. So next slide, please. So for a long time, many saw climate change as the business of governments and diplomats, these international meetings, the conference of parties and so on. And they figured that, okay, climate change is an issue. And I can tell you, for many years in my country, people thought that climate change was all about polar bears and so on, and ice sheets melting, and it would not affect them. It would be long after they're dead. But I think now everyone feels it, although I said almost, because there's some people who deny that climate change is happening. They figure it's just a hoax. It's, they deny that climate change is happening. But as the famous reggae singer Bob Marley said, who feels it knows it. And I think we're all feeling something. We're all feeling that it's getting warmer. We're all seeing the changes in temperature. So the point is that climate change is no longer the business of governments and negotiators. It affects all of us. It affects where we live, how we live, and so on. And to get everyone involved, we need to firstly understand how people view and understand climate change and plan our actions around this. Okay? We can't just tell people you must do this and that without understanding how they engage, how it affects them. How does it affect the farmer whose seeds will not germinate in the field because it's too hot, or his crops are washed away by flooding that's coming outside of the expected season. Engage people from the ground up and work with them to develop and apply appropriate and impactful solutions. Okay, that I think is critical. Next slide, please. And one approach that I can tell you, we can talk about is ecosystem-based adaptation, which is the use of biodiversity and ecosystem services as part of an overall adaptation strategy to help people adapt to the adverse effects of climate change. And if it's effectively implemented, ecosystem-based adaptation, which is really using nature-based solutions where possible, and not just coming in with a mechanical build a wall, but using nature as much as possible, using natural systems, can help to sustain livelihoods, build community resilience, reduce the financial cost of adaptation, and reduce the need for repeated project-based interventions where you have to come back every 5 years and rebuild a wall or something of that sort. So I will just move to the next slide, please. And coupled with that is the need for gender and social inclusion. We have to focus on delivering equal rights, opportunities, and mainstream services to all citizens, including women, the poor, and the marginalized, because very often different groups of people in our communities, and especially vulnerable people, are affected differently by climate change, which might seem to be a global phenomenon, but locally it affects people differently. Okay, so we have to recognize the gender differentiated response vulnerabilities to climate change impacts, as well as the differentiated strengths. In other words, how do men react? How do children react? How are they affected? What are the strengths they can bring? In some communities, women are the mobilizers. In others, it's the men. Okay, in certain sectors, in fishing, for example, you might find, for various reasons that the men may be better placed, or the women, whatever. So we have to take this into account, and we also have to consider the particular vulnerabilities of the marginalized and high-risk social groups, such as the poor, the elderly, the children, mentally and physically challenged, and so on, to ensure that whatever methods, whatever we take, steps we take for adaptation, they work and they're adaptive or appropriate to the situation. The point is, I think also that we have to recognize that, you know, we talk about the science, doing the research in terms of, you know, counting how many fish or how the fish move and so on. But there's also a lot of research and learning that can take place in understanding the social dimensions of climate change, the economic dimensions, and understanding how to bring people along, how to empower them and engage them and so on. So there's a lot of work that can be done in this area. And next slide, please. Recently, the OECS has launched a toolkit to promote ecosystem-based adaptation and gender and social inclusion, again with the kind support of AFD, Agence Française de Développement, on the Adapt Action. And Elodie's here. Elodie, thank you. Take a bow for this. And that toolkit is available on the OECS website, oecs.org. So you can access it there. And so it's certainly something that I think you should consider, you should take a look at. And with that, I think I just want to go to the next slide and say thank you for your attention. Merci beaucoup. That's it for me, guys.
Merci beaucoup, Crispin. Thank you a lot, Crispin, for this overview, if I may say so, on the subject. It was really insightful. We are going to pass the floor to Sarah Gaspar. Let me just look for your presentation, and then we'll be able to go on.
About sargassum.
About sargassum, yeah.
So my talk is...
Go ahead, sorry.
Thank you. So my talk will be about the possibility of recycling of sargassum for activated production. So in the Caribbean, we are now facing massive invasion of sargassum, brown algae. So they come from, close to Brazil, and they arrive to the Caribbean Gulf, Mexico, West African, and Brazilian coastline. So all the sargassum covers the beaches, and we have sometimes more than 1 meter of sargassum. The hypothesis that we have now that it comes from climate change, as the water are warmer, and also because the nutrients coming from Brazil's Brazilian agriculture may be cause this blooming of sargassum. So we have many health, environmental, and economic impacts, because environmental impact, because the fauna and also you have some plants are impacted by this high quantity of sargassum, because it consumes a lot of oxygen, and for this reason you can have the water becomes poor in oxygen. So there is also an health impact, because sargassum can produce a lot of toxic gas, sulfur gas, and due to this gas, people can have allergies and some health impacts. The other impact is as well economic. How has our highlands of industrial, touristic, and fisheries industries that is impacted by these high quantities of sargassum, because the beaches are not accessible to people, and also the boats of the fishermen cannot access to the water. So it becomes a big problem in the Caribbean, and it is now necessary to find some solution. So there is different aspects for the solution. First, a solution to get rid from the sargassum from the beaches, so to use appropriate engines to get rid from the sargassum. And the second is what to do with the sargassum. And we are working in our laboratory on this aspect of what to do with the sargassum. And we are thinking of valorizing this biomass in activated carbon. What is activated carbon? Activated carbon are carbon materials that are produced. There were many produced from mineral carbon. Nowadays, there are many produced from biomass and mostly from coconut. And those materials are very porous. So you can see here the pores that you have in this material. And due to this porosity, then can be used for many applications, for air or water treatment, but as well for food processing, pharmaceutical application, and also energy storage. So in our laboratory, we are involved in producing activated carbon, so valorizing this sargassum, first for remediation, for pollution treatment and pollution sequestration, and also for energy storage. So the different applications that we are working on are the use of those sargassum activated carbon for pesticide sequestration in animals, and also for energy storage, as well for water treatment. For example, I will give some example regarding pharmaceutical compounds, and also it can be used for capacitive deionization for water treatment. So why sargassum can be interesting for producing activated carbon? So they are a natural carbon source. They contain a lot of carbon. They also contain a high variety of chemical groups that can be useful, for example, for some application in energy storage. And of course, it's a highly available biomass and cheap. So I will present you how activated carbon can be prepared. So the fabrication of activated carbon needs first a pyrolysis, which is made at a temperature between 500 and 700 degrees. And then we have what we call an activation. The role of the activation is to create some porosity, because as I told you, the porosity is very important so that the molecule can be fixed inside the material. And we also use what we call a chemical impregnation. So the biomass is impregnated with a chemical agent, and then there is a pyrolysis, and then we produce the activated carbon. And we can also use hydrothermal carbonization with an impregnation and then a pyrolysis. So I will show you the first application of activated carbon. So they can be used for batteries production. I mean, batteries such as supercapacitor. What are supercapacitors? Supercapacitors are batteries that are able to release energy in a short time, that are used, for example, in electric vehicles, tramways, wind turbine, or also computers. They are composed of highly porous materials such as activated carbon. There is also a separator and an electrolyte that you can see here in this scheme. So when you apply a potential, there is some positive charge that remain on the plate and negative charge, and then you can have a charged state, and during the discharge state, negative and positive charges are released. So we are preparing activated carbon from pelagic sargassum that are dried, crushed, and then we do pyrolysis. And we have another way to prepare them using hydrothermal carbonization. So we can study the composition of this activated carbon and to optimize their properties. So for example, I will show you, so the textual characterizations that we do, we mean that we characterize the porous material, our quantity, what is the size of the pores that we have inside the material, because pores are very important. The higher the surface of the pores is, the higher the amount of molecules trapped inside the carbon is high. And we can also characterize the surface chemistry, so with elemental analysis, surface functional group, and also what is the most important, we analyze the electrochemical properties of our carbon, and we do for what we call the pollutant study, adsorption studies, to study the fixation of pollutants. So I will show you the structure of the carbon obtained from sargassum that you can see here. So here you see the kind of elements that we found in the sargassum: carbon, oxygen, carbon, a majority. We find some natrium, aluminum, sulfur, chlorine, etc., calcium. And then you can see the elemental composition. So we find also some nitrogen, silicium. And here you can see the BRT surface area. The BRT surface area is the surface of the carbon. So when you consider a pore has itself a surface. And if we stack all the pore together, you can have high surface area. For example, when you have 1 gram of activated carbon, you can have, for example, about 600 square meter of surface inside the 1 gram of activated carbon, which is very high because it's about a football camp surface. So we can determine what kind of pore we have, if we have small pore, big pores, or that is important also to know what kind of molecule can be fixed inside the carbon. So here you see the kind of electrochemical studies that we have and that we can study, what we can find with the activated carbon prepared from sargassum. We have good results. And we find, for example, the capacitance, which is a parameter which is used to characterize the electrochemical properties of the activated carbon, and we find some kind of good results. And here we can compare what kind of capacitance that we have for all the biomass. For example, we have cassava peel that we can also use for preparing activated carbon, cherry stones or bamboo, firewood, banana fibers are also used. So we have some data which have capacitance which are very close from what we find for sargassum. So other application is, for example, we can study how we can fix some pollutants. So we know that pharmaceutical compounds can be found in water, and it is necessary to treat some the water to produce drinking water. For example, we used here diazepam, which is a compound, a pharmaceutical compound, and we can find high adsorbent. Here, for example, we found that we can fix about 300 milligrams of diazepam in 1 gram of activated carbon. Okay, so which is on a commercial activated carbon. And here we can compare it with sargassum activated carbon, and we found data which are about 100 gram of diazepam fixed on activated carbon obtained from sargassum. So we also work on caffeine here that you can see here, and we find also that we can fix about 150 gram of caffeine on activated carbon prepared from sargassum. So we work also on chromium adsorption to know if we can also fix metal on activated carbon. And we found also interesting results, which are similar from the one we found for a commercial activated carbon. That means that we can use activated carbon prepared from sargassum for treating water. So another project that we have is to try to know how we can prepare activated carbon from sargassum to limit the availability of organochloride pesticides for animals. I mean, or for producing animals and for producing a safe food. So here, for example, we use different sargassum that we prepare by different treatment, and we could determine that we can prepare what we call a biochar. A biochar is a sargassum which is prepared without activation, but only with pyrolysis, and we could obtain also a reduction of availability of the pollutants. So we have, for example, when we have a 100%, it means that all the pollutant is available to animals. So the food is going to be polluted, but we can reduce the availability to less than 20% when we pour some activated carbon in the food of the animals. So what we can conclude is that we can prepare activated carbon with different procedures, and that we can have good activated carbon from sargassum with interesting electrochemical properties. And also, those sargassum activated carbon can fix pollutants such as organochloride compounds, or also chromium, and also pharmaceutical compounds. So here I can say some acknowledgement to the people, the partner working with us on these different projects. Okay, and thank you for your attention.
Thank you very much, Sarah. That was very detailed, very technical. I'm not sure I followed everything, but that's what questions are for.
Okay.
Maybe we can quickly ask you the questions before Elodie goes on with her presentation, because we know you have to be leaving by 1 imperatively as you have class. So I do have one question. So I'm reading, dear Ms. Gaspar, I am not sure if I understood well, and how can we use this carbon and for what sorts of activity? But actually that was the topic of your presentation, but maybe could you in maybe 1 or 2 sentences make it very simple for us to get what kind of substance is doing what to this sargassum issue?
So you want me to explain more simply?
No, just in a nutshell, maybe I get that it's a huge amount of work and a huge project, especially because the sargassum is a huge issue, especially in Martinique, where I am right now, and I know that it has huge impacts on health and tourism and the economies also on the islands, but more like in a clear way, we could say that activated charcoal is one way to kind of purify the waters. Is that it?
Yeah. So activated carbon is the most used material for purifying water. Actually, it is used everywhere in the world. And as I said at the beginning, there is 1.9 million of tons of activated carbon produced all over the world. And the demand of activated carbon is becoming higher and higher because the environmental laws are more drastic, and there is a need of cleaning the water because as well, human activities has a lot of impact on water. And there is a need of having a clean water for producing drinking water. Yeah.
Definitely.
So we are thinking of sargassum as a big problem. We are sure of that. But also it could be a kind of opportunity to have a cheap biomass, you know. And it's true that before having this kind of application, we have to make a lot of studies of chemical studies. First, understand how to produce the activated carbon, which is, and how to process the sargassum to have a good quality of activated carbon that could really be used. So it's why there is a lot of kind of characterization, chemical characterization, and we also make the characterization of the pores and everything to know if it's really an activated carbon and a good activated carbon. So that it's the main point. And the other point that we need to do is, you know, that sargassum can trap a lot of pollutants in the water. So it is necessary to do this characterization. It is very important. And then when you have a good activated carbon, you see that the properties are interesting, chemical properties and surface properties. You need to make some tests to see if you can really use it for fixing a pollutant, a given pollutant. Okay, so we make these studies of kinetic studies and everything to understand that. And another application that we found very interesting, and which is because we need to store energy. That is a big challenge. Yes. For having renewable energies. Okay, so energy storage is a challenge that can be faced by using porous material coming from biomass. And the biomass can be seen how as a renewable resource, because it's true, activated sargassum, we can have sargassum very often, and this biomass is not so much used. So it can be seen as a raw material for producing batteries. So it's one of our objectives. Okay, I hope that it is.
Yes, that's clear. I think that's clear for a lot of us, at least. The same person who asked the question is saying, sorry, my question arrives early in the presentation, and you did answer afterwards, but a little resume helped her to understand better. So thank you very much. We do have other questions. I just want to get this over with kind of quick, because we also have Elodie who is waiting to proceed with her presentation. So first question, sargassum invasion is not permanent. Is it possible to conserve it? And also, what about producing electricity with this biomass, the gas released and the environment? So I hear that it's a very wide subject, so maybe you could answer the first question. I don't know if we will have time to answer the second one. So yeah, is it possible to conserve it?
Yeah, it's possible to conserve it. It can be dried. So in the lab, as we know that sometimes there is sargassum, sometimes not. So we dry the sargassum and we keep it. We can keep it at least 1 or 2 years. Yeah. So it's possible to conserve it. So of course, if you go to an industrial phase, you have to make the calculation of energy needs for this drying. So now we dry it in the sun. You know, we don't use much energy to dry it. Yeah.
Okay, well, great. That was complex but still very fascinating. Thank you very much, Sarah. We will proceed with now Ms. Afonso's presentation.
Thank you.
Okay, one sec. I'm just trying to upload it. There we go. Here we go. So we're ready to start, and the floor is yours, Elodie.
Thank you. Bonjour à tous et à toutes. It's actually a real pleasure for me to present you this AFD-funded program entitled Adapt Action, and to participate at this first edition of the virtual student fair. And first, thank you, Serena, and all the team from Elan Project for the organization and invitation. Next slide, please. So, due to the geographical location, geological and topographical features, but also, as Crispin said just before, the socioeconomic profile, Caribbean territories are disproportionately vulnerable to the effects of climate change. And this vulnerability makes them sentinel territories. And by sentinel territories, I mean they illustrate the possible adverse consequences of climate change on a global scale. But on the other hand, or at the same time, Caribbean states can also become real laboratories for local and regional innovation in terms of adaptation. Next slide, please. So manifestations of climate change in the region are very real. And according to the IPCC, average temperatures in the region have increased over the last 3 decades, as you can see in the first figure. Precipitation patterns have changed in the region, and the number of consecutive days, dry days, has increased. In addition, the sea level has risen, and at a rate of about 2 to 4 centimeters per decade over the last 30 years. And I would illustrate this with the case of Cuba. The Cuba's coasts, for instance, are already affected by coastal erosion for 82% of them. This is a shared trend in all the Caribbean, poses significant risks to the region's freshwater resources, and considering also the coastalization or littoralization of populations and infrastructures threatened by flooding. For the end of the century, climate models predict an increase in the manifestations of climate change, such as increase in average annual temperatures, but also more heat waves, decrease in annual rainfall of around 12%, and decrease of frequency of category 4 and 5 hurricanes. Next slide, please. Yeah, thanks. High vulnerability to and potential for climate impacts throughout the region often drives direct integration of climate risk management into countries and regional planning and processes. And I would like just to take a quick aside in order to recall the conceptual framework of the 5th IPCC report, which allows us to understand climate risk as a result of the interaction between vulnerability, exposure, and danger. And according to the indicator developed by Andy Gain, this is the second graph figure on this slide. Caribbean countries can be classified into 3 groups. And here in red, sorry for the quality of the graphic, but we can see Cuba and the Dominican Republic have a high level of vulnerability to climate change combined with a low level of preparedness. These countries have significant needs in terms of investment and innovation to improve their preparedness capacities and require rapid adaptation actions. On the other hand, in blue, we can see Antigua, Dominica, and St. Kitts and Nevis, that are countries which are particularly vulnerable to climate change, but have a good level of preparedness. Nevertheless, adaptation needs remain significant. But it is to say that we can also work on regional cooperation in all the Caribbean region in order to foster capacities of the different territories. Next slide, please. Let me so present you very, very briefly how climate change is a cross-cutting issue, since Crispin already drew a presentation of the different sectors. But I will focus maybe on the specific case of the increasing frequency and intensity of extreme weather events, which are very important risk factors for the Caribbean populations, ecosystems, and economic activities in the region. And just to talk about the 2017 hurricane season, Hurricane Maria affected more than 160,000 people around the region, and Maria again caused around 1.37 billion US dollars in damage in Dominica. So population and key infrastructures are typically in coastal areas, as we say, and facing increased risk from tropical storms and sea level rise. And just for your information, of the top 20 countries in the Coastal Risk Index, 7 of them are in the Caribbean, including Belize, Jamaica, the Bahamas, and Guyana. Next slide, please. So since Crispin already gave a good overview of agriculture as a critical component of the economies in the Caribbean and very sensitive to climate, I will maybe focus on tourism, since the tourism sector is also the largest industry for the region. We know that a lot of GDP or Caribbean GDP depend on it. However, climate variability and change threaten the different features of tourism in the region. And it's true that, just to take this example, that most hotels and resorts are located close to the ocean and low-lying areas. Next slide, please. So I would say that, considering that adaptation to the impacts of climate change is thus a great importance for all countries in the Caribbean region, while projections indicate that the cost of inaction would represent 10% of the Caribbean's annual GDP in 2050. So this is a real issue for all the sectors and all the different components of our societies. That's why since 2017 and the One Planet Summit held in Paris, the adaptation facility supports among 15 developing countries and regional organizations in Africa, in the ocean, in the Indian Ocean, and in the Caribbean, in order to help them meet the challenge of making the Paris Agreement operational by implementing adaptation dimensions of their climate commitments, what we call NDCs. In the Caribbean, our main partners in this framework of the adaptation facility are Cuba, the Dominican Republic, and the OECS Commission, represented here by Crispin d'Auvergne. So the objective of this so-called facility is to provide the most vulnerable countries with the means to generate sound investments projects in the area of climate change adaptation that can be financed by development financial partners such as the Green Climate Fund and or l'Agence Française de Développement. Thus, in consultation with national authorities and the OECS Commission in this case, IFD coordinates specific roadmaps that contribute to the creation of an enabling environment for adaptation and also the development of climate change adaptation innovations. Next slide, please. So first, adaptation is therefore a catalyst for changes that promote tomorrow's climate investment by strengthening climate governance first and supporting the integration of adaptation into sectoral public policies. As I said, first, the climate emergency calls for rethinking the different scales of climate governance and climate policy. As such, at the supranational level, adaptation has been supporting the OECS Commission in order to develop a regional adaptation strategy, taking into account gender, covering all its members and associates. This work is based in particular on improving the knowledge of OECS stakeholders on climate trends. On the other hand, because national climate objectives can only be achieved by integrating local actors, and by local actors, I mean municipalities. In the Dominican Republic, the facility supports the National Council for Climate Change to strengthen the role of municipalities in defining and implementing adaptation strategies. Next slide, please. Secondly, adaptation promotes also a paradigm shift beyond climate co-benefits by mainstreaming climate change adaptation into sectoral policies such as agriculture, tourism, education, urban planning, health, or even social protection. And I will focus on what we have been doing with the Dominican Republic, and particularly with the Dominican Ministry of Agriculture since 2019. The facility has been supporting, therefore, agriculture actors in this country in order to assess the vulnerability to climate change of main agriculture chains, including cocoa, coffee, banana, rice, and bean. And this support also aims to define specific adaptation measures for the most vulnerable production systems, which are particularly important in terms of food security for the country. Simultaneously, knowing that 50% of the Caribbean people lives less than 1.5 kilometers from the coast, urban planning has been identified as a priority sector in Cuba and by the OECS Commission. In Cuba, adaptation provides a specific support to the city of Cienfuegos in assessing the climate risk, the current and the future climate risk of its territory, taking into account the current urban growth dynamics and also the strategy, the local strategy to develop its seafront. And the studies should lead to the definition of concrete adaptation measures where urban heritage, historical heritage, and urban agriculture issues will require particular attention. Next slide, please. Furthermore, because access to finance is still one of the major challenges for the implementation of climate commitments, particularly in relation to adaptation, the facility supports its Caribbean partners in order to formulate and design climate co-benefit investment programs. In the Dominican Republic, again, the facility and its national partners, including the Ministry in charge of Economy and Social Affairs, but also NGOs, have been working in order to formulate an investment program to strengthen the resilience of populations and the poor ones in the Yaque del Sur watershed. The outcome of this feasibility study aims to strengthen the nexus between social and climate justice, in particular by developing adaptive social protection mechanisms whose dual objective is actually to first protect the poorest against climate shocks and extend to other sections of the population affected by climate events, and second, to avoid any adverse impact on natural resources or creating negative externalities. Next slide, please. On the other hand, the facility aims to accelerate innovation in climate change adaptation by first promoting nature-based solutions, or what we call also ecosystem-based adaptation, or eco disaster risk reduction. Second, developing climate services. And third, developing innovating risk finance mechanisms. Regarding, for instance, nature-based solutions in Cuba, the authorities have requested a specific support from the facility in order to develop marine protected areas and to strengthen their role in terms of regulator and capacities to adapt to climate change. Secondly, when I talk about climate services, I mean that climate services play an important role, particularly for climate-sensitive sectors, such as agriculture, in order to improve the capacity of farmers, for instance, to reduce or even anticipate risks and adapt their activity to climate variability. And since last year, Adaptation has been provided technical support to the Dominican Met Institute in order to improve the entire value chain of climate services for the Dominican farmers. Finally, adaptation has been supported since 2018, the OECS Commission, in putting into practice at a regional level an innovative approach to build resilience by combining weather forecasting and risk analysis. These mechanisms, known as forecast-based early action, has been developed by humanitarian actors and seek to mitigate the consequences of extreme events such as drought, floods, or even hurricanes by identifying early actions to be taken based on weather forecasts and according to predetermined alert triggers. Next slide, please. In other words, and to summarize, manifestations of global warming are real, visible in the Caribbean, and will continue to increase. Climate change burdens development trajectories of all Caribbean states, and we do have to accept and manage uncertainty as an imperative. This presupposes a change in the attitudes and behaviors of all the components of societies, and therefore an interdisciplinary approach. And to respond to that, through the Adaptation Facility, partners countries benefit from more than 2,000 days of expertise, local, regional, and international experiences from private actors, research institutes, or even civil society organizations, by also the mobilization of concepts, methods, and tools from engineering, environmental, political, and social sciences, and from a range of complementary tools, technical assistance, participatory approaches, vulnerability studies, and feasibility studies. Then the development of relevant adaptation measures must favor a systemic, dynamic, and multidisciplinary approach. Next slide, please. And well, thank you. Merci à tous. I'm ready to answer to your question. And if there is not enough time, please feel free to drop me a line at the following email address. And well,
okay,
that's all.
Thank you very much, Elodie. We do have 2 minutes left, so if there are questions, visitors, don't hesitate. Sarah, I see you had the opportunity to answer to the question in the chat, so thank you very much.
Thank you, and I will leave, so I say thank you and bye.
Okay, thank you very much. Bye-bye. Bye-bye, Sarah. Bye-bye.
Bye-bye.
Okay, I did have a question for Crispin, though. You talked about the gender and social inclusion part of what you're doing, the OECS. Would you have maybe a concrete example about that? Because I'm personally very interested in this side of this perspective on climate change and vulnerability as well.
Okay, thanks. I guess I can, to draw back from some of my experiences way back when, going back a couple of years now, and I'm talking when I worked with the government of St. Lucia, just to give an example I'm very familiar with. There was some charcoal producers, there was some charcoal being produced from mangroves on the east coast of St. Lucia, a place called Savannah Bay. And the people were cutting the mangroves, you know, for firewood and to make charcoal, actually. And the forestry department at the time, the natural inclination in those, at the time would have been, okay, the mangrove is a protected area, stop the cutting. But what they did, they consulted the community. So that's an example of social inclusion. Okay, what is driving the cutting? Why do you cut? Okay, we do this for our living and so on. So, okay, if you cut the trees in a way that they can grow back, and you don't cut all the way down to the bottom, but you cut it so that they can copy, so they can regrow, okay? And you do it on a rotation system, then you're able to continue producing, okay? Indefinitely, the trees will regenerate and so on. And so that particular set of farmers had a set of, that particular lot where they worked, or that set of lots, and it was done on a sustainable basis. But all because the forestry department didn't just say, okay, stop cutting, or just allow it to go indiscriminately, but because they consulted the community, and there was that element of co-management, and also because there was that engagement with the community to understand what are the drivers, what are the needs, and so on. So that is just one example from the social engagement standpoint. And the time is short.
Okay, thank you very much. We have some questions. Maybe we can take a few minutes to answer them.
Sure.
Questions to Mr. Dauvergne again. What are the possibilities and challenges of exploring desalination as a solution during droughts in some of the OECS countries? And is this something that has been considered in the OECS?
Yes, actually, there are a few desalination plants operating. For example, in Antigua, because Antigua, relatively speaking, is water scarce, and they have some desalination plants operating. One of the challenges that occurs, that exists with desalination, of course, is two things. Well, there are a number of challenges, but technologically, one is that it's energy intensive, and two, when you do desalination, the hypersaline brine, the very extremely salty brine, if you don't dispose of it properly, it can cause a severe environmental damage, where it is discharged. Now, on a small scale, in islands like Bequia in St. Vincent and the Grenadines, they actually have a solar power desalination plant that was established some years ago, and it worked pretty effectively, and it fed excess energy to the grid as well. On the other hand, there's a local developer in St. Lucia who developed a solar-powered portable desalination plant, and he had also developed a proprietary process for treating the brine so that to reduce the salinity, and so it can be disposed of into the ocean with minimal ecological damage. So there are opportunities. Some of these approaches need to be upskilled. There's probably still scope, I guess, for refining the processes, but yes, there are possibilities. Yes, it's being done. I mean, there is desal, and there are some interesting approaches.
It's being explored. Okay, thank you very much. I think we are going to have to wrap up. If you have questions for Elodie, you can still note her email address. You can also visit still our booth on the virtual fair, and we will be happy to give you her contact if you have any questions for her. I'm thinking about maybe some projects that are led by the AFD on maybe French Caribbean territories, such as wind plants. I heard about this one and all of this. So, and also we have Crispin's address in the chat. Don't hesitate to copy it and to paste it somewhere and to keep it somewhere if you have any questions for him. Of course, it's a very wide subject. We did not have time to broadcast Professor Safash's podcast, but it will be made available to you along with his PowerPoint presentation. And I think it's time for me to wrap up and to tell you thank you very much for being here and for these insightful analysis, and we will be seeing each other soon, hopefully, with this whole COVID thing for real this time.
Thank you. Bye-bye.
Thank you very much.
Thank you for the opportunity. I enjoyed this. Thank you very much. And everybody keep safe.
You too.
Bye.